Jai Hind all. The topic which we are going to discuss today is IoT, that is Internet of Things. So basically when we say what is IoT, so IoT is nothing but it is a connection of a variety of things, as you can see in this figure, and all these things, they have the ability to communicate with each other. And once we are saying that they have the ability to communicate with each other, what it implies, that is all these devices, they are having or they can acquire IP address. If they have the ability that we can assign IP address to these things, then these things can communicate over the internet with each other or with a human being. So these are the various definitions you will find for the IoT. According to Wikipedia, it says it refers to a wireless network between objects. Usually the network will be wireless, and this network is going to be self-configuring, such as household appliances. That is, since we can see in this figure that most of the devices, when we say wire cannot be possible for the communication. So most of the time, the network in which these devices are communicating, it is a wireless. It is a self-configuring, that is, the devices, they are coming into the network and they are leaving the network without affecting the network. For example, your household appliances and so on. When you are using a household appliance, it will come into the network, and if you are not using it, then it will remain out the network. Then in 2008, another definition of IoT comes. It says that IoT, it describes a number of technologies and research disciplines that enable the internet to reach out into the real world of physical objects. At that time, in 2008 approximately, the technologies, they are not well sophisticated. So this is the most appropriate definition of the IoT at that time. But later on, with the advent of the wireless technologies, the devices, they are becoming more cheaper, more smaller. So a new definition of IoT comes in 2020, and what it says, that things having the identities, that is these things, they could have their own identity. They are having their own virtual personalities, and all these things, they are operating in a smart space using intelligent interfaces to connect and communicate within social, environmental and user context. This is a simple diagram which is showing that how the IoT is growing, and still we can say that the IoT concept, the devices which we are using in the IoT, the network of the IoT, it is ever growing. So what are the key features of the IoT? The first thing is AI, because the devices, they are able to communicate with one another. These devices, they are having the smart ability in them, that is, they can make the decision on its own. For example, if we say that we are having a smart watering system, then in that case, what is happening, if the field, when we water a field, or we say when we water a pot and it reach a saturation point, then automatically the tap got overturned. There is no human intervention, so we are having sensors in that pot, which is sensing the level of a water, or you could say which is sensing the humidity in the soil, and according to it, it is taking a decision when to switch on the tap and when to switch off the tap. So we are having that these things, they are virtually smart. So meaning it enhances every aspect of life with the power of data collection, AI algorithms and networks. This can mean something as simple as enhancing your refrigerator and cabinets to detect when the milk, your favorite cereal or your fruit is out of place, and then your fridge is making a decision on your behalf and ordering or sending an order to a vendor so that that particular item, it can be delivered at your doorstep. Connectivity, This is another important thing because all these devices, they are communicating over the wireless network. So we need a connectivity. So new enabling technologies for networking, especially your 5G, 6G and so on. And specifically IoT networking mean networks are no longer exclusively tied to major providers. Networks can exist on a much smaller and cheaper scale while still being practical. IoT creates these small networks between its system devices. Sensors, we do need a sensors in IoT. So IoT loses its distinction without the sensors. They act as defining instruments which transform IoT from a standard passive network of devices into an active system which can integrate with the real world. Active engagement, that is much of the today's interaction with connected technology happens through passive engagement. So IoT introduces a new paradigm of active content, product or service engagement. Devices, they are very small. So devices, as predicted, they have become more smaller, more cheaper, and they are also becoming more powerful with the time. So IoT exploit all these features of the small devices to build a specific purpose IoT network which can deliver its precision, its content or its decisions with precision, scalability and versatility. In an IoT system, as we can see, we could have a IoT hub. This IoT hub, it is connected to the IoT devices, and these IoT devices, they are sending some data to the IoT hub, and this IoT hub in turn is sending commands and RFIs to these sensors. This IoT hub is connected to the internet network. Again, it is sending some data, and your internet network, it is sending some command or request for information. This internet network sending the data to the IoT companies or IoT users. These IoT companies, they are sending the data to the analytics or to IoT remote systems which are commanding or sending the commands to the internet network according to their use. So this is a basic IoT system, that is, we are having sensors, then we are having IoT hub. It comprises of processors or processing power. Sometimes these systems, they are existing on the edge, on the edge of your system. So sometimes the local decisions, these IoT hubs, they might have a power to take the local decisions, and if they are not capable of taking the decisions, then they are sending the data to other IoT companies, platforms, IoT platforms or the IoT users which can take decisions on their data. So these are the enabling technologies. As we have seen, we need RFID, we need sensors, we need smart technologies, we do need nanotechnologies because we need smaller devices. What are the advantages when we say but then we should go for the IoT? The very first advantage is improved customer engagement. Current analytics suffered from blind spots and significant flaws in accuracy. So IoT completely transformed this to achieve richer and more effective engagement with audiences. Technology optimization. The same technologies and data which improve the customer experience also improve device use and aid in more potent improvements in technology. IoT unlocks a world of critical functional and field data. Reduce waste. IoT makes areas of improvement clear. Current analytics gives a superficial insight, but IoT provides real-world information leading to more effective management of resources. Enhanced data collection. IoT breaks it out of those spaces and places it exactly where humans really want to go to analyze. It all allows an accurate picture of everything. But yes, it is having disadvantages also. For example, when we go for the security, as we have seen in the IoT ecosystems, that the sensors, they are sending the data to the IoT hub is connected to the outer world and so on. So this connected devices, they are communicating over the networks. These networks, most of the time, they are wireless networks. So the system offers little control despite any security measures. This leaves users exposed to various kinds of attacks. Privacy. This is another important issue. The sophistication of IoT provides substantial personal data floating over the network without the knowledge of the user. Complexity. Some find IoT systems complicated in terms of design, deployment, and maintenance, given their use of multiple technologies and a large set of new enabling technologies. So, yes, the network which they are forming, the devices which we are saying that they are smart devices, sometimes the network becomes complex. Flexibility. Many are concerned about the flexibility. That is, the devices sometimes they are not easily integrated into the system, into the network, and sometimes the protocols on which these since these are the variety of the devices we are using in a IoT network, and sometimes they are incompatible to operate with each other. So it is problem in finding the in resolving the conflicts among these devices. Compliance, that is a standard, this is another important disadvantage. So like any other technology, IoT in the realm of business must comply with regulations, but its complexity makes the issue of compliance seems incredibly challenging when many considered standard software compliance a battle. Now come on the physical device design of IoT, that is the things we are going to discuss. What is this word thing literally means? It usually refers to IoT device which have unique identities and they can perform remote sensing with the help of sensors. They are having actuators, that is, they are the devices which are taking decisions, which are taking actions on the basis of the decision and have the monitoring capabilities. So IoT device, they can exchange the data with another connected devices. They collect the data from other devices and may process the data locally or send the data to centralized servers or cloud-based applications which are having backend. These applications, they are running as a backend on these servers and they can process the data which are generated by these IoT devices, or they may perform some task locally and other tasks within the IoT infrastructure based on temporal and space constraints. For example, if I am talking about the weather forecasting, then we could have a weather forecasting for a particular area where the local decision is being taken, but we could this data, it can be shared with other areas, with other locations also. So on the basis of this collective data which is being generated from various sensors, a collective decision on a region or a particular you could say city or a region, for example North India or South India, if we want to make a decision that what kind of weather is predicted in North India or South India, so we can make a global decision in that case. So these devices, they are capable of making a decision locally as well as making the decision on a global aspect also. So physical things, they exist in the physical world, but we are having virtual things also. So when we say the things, they have been categorized into two. One is the physical thing and another one is the virtual thing. So when we say the physical thing, they exist in the physical world and are capable of being sensed, actuated and connected. Examples, they may include surrounding the environment, industrial robots, goods and electrical equipment. Virtual things, they can exist in the information world and are being capable. You can store these virtual things, you can process on them, you can assess them. Examples include multimedia content and application software. So in this particular diagram, this is the devices, things available in the physical world, and this is the information world. In the physical world, we are having the devices We are having the gateways, that is, if this device wants to communicate with this device, then it need a gateway. We are having the physical thing, that is, which is shown with the help of you could say solid circle. Then corresponding to these physical thing, we are having virtual things. Now corresponding to a single virtual physical thing, we could have multiple virtual things available with us. Communication, we are having three categories of communication. Communication via gateway, that is this communication. Then we are having communication without gateway, that is these two physical devices, they are communicating with each other but no gateway is involved in that case. And sometimes if the devices, they are located or they are in a local environment, then they can interact with each other directly. So this is a direct communication. The IoT, it works on any X concept, that is, you could use these devices, or these devices, they are able to communicate with each other at any time and they can work in any context. Anyone can use them and anybody can work on these IoT devices. Any service or any business can get you could say benefit from the IoT network. Any path, any network can be used, that is, you can have a wired, you can have the wireless. Any place, anywhere concept, that is, these devices, they can be deployed in any place at any location. Anything or any device, that is, you can operate on these applications, IoT related applications, by using the thick client or by using the thin client. When we say anytime, any place and anything, and with the help of these three, we got a three-dimensional concept. So when we say anytime communication, so it says anytime communication says you can do the communication on the move, anytime, night, daytime. If we say any place communication, it could be outdoor, it could be indoor, it could be on your system. Anything communication, it says it can be between the computers, it can be human to human, it can be human to thing, or it can be thing to thing. When we say IoT, we can say IoT can be seen everywhere. We could have a consumer and home, we could have IoT over there, we could have smart TVs, we could have a smart fridge, smart watches, smart washing machines, smart ACs, smart printers. When we go with the smart infrastructure, we could have the smart heating systems, we could have smart corridor lighting systems, we could have the IoT in security and the surveillance, we could have IoT in transportation, in industrial, retail, healthcare. So we can say IoT is everywhere. So IoT applications, as we have seen it, we are having in all the sectors, we could have the IoT. So on the basis of these, we can say we could have smart cars nowadays, we are having wearables, smart appliances, smart buildings, smart homes, smart farming, smart health, and so on. So smart world, when we say what is a smart world, then we could, this particular thing has been given, I have taken from this particular website. So according to this smart world, we could have the smart roads. In the smart roads, we could have the warning messages and diversions. According to climate, we are having smart lighting, intelligent shopping, noise urbans, we could have waste management, smart parking, we could have the IoT in water quality, and so on. We will discuss this particular, all these things later on when we come towards the smart city, when we discuss the smart city concept in other video. So when we say, these are the few examples, we could have helmet, helmet concussion sensor, we are having medical alert watch, we are having smart fitness clothing and smart running shoes available with us. We are having one button product purchases nowadays. We are having garden sensors, we are having smart TVs and so on. So these are the few examples. For example, in the helmet concussion sensor, so you could say this is a simple example of a concussion sensors which has been deployed on the helmet. Another example from the Amazon, we are having the Amazon Dash thermometers in the healthcare. We are having the cars, connected cars. We are having smart farming. So in the smart farming, where we are using the IoT to improve the agriculture. So in the IoT based smart farming, a system is built for example, a system is built for monitoring the crop field with the help of sensors. Sensors which we are using over there, they could be my light, humidity, temperature, soil or moisture sensors. Automating, which is being used for automating the irrigation system. The farmers, they can monitor the field conditions from anywhere, and this is highly efficient as we compare to the traditional approaches. In terms of environmental issues, IoT based smart farming provides great benefits. For example, better and efficient water management, optimization of inputs and treatments. Therefore, a smart farming based on IoT technologies enable the growers and the farmers to reduce waste and enhance productivity. And due to this, we could have the precision farming, we could have agricultural drones available, livestock monitoring, smart greenhouses nowadays, and so on. Another important concept in the IoT, where we are using the IoT majorly in the industry, and this a new term has been coined, that is IIoT, industrial IoT, and it basically focuses on the cyber physical systems which is being used to monitor the physical factory processes and making the data based automated decisions. While the physical systems are made the intelligent using IoT, the real time communication and cooperation both with each other and with humans is established via the wireless network. So IoT, when we say IIoT, it means a connected factory which leads to a smart factory. We could have the IIoT in manufacturing, where we are having the digital or the connected factory, and in this IoT enabled machinery can transmit operational information to the partners like original equipment manufacturers and to field engineers. In the facility management, we could have the IoT sensors in manufacturing equipment which enables the condition based maintenance alerts. We could have the production flow monitoring, where the monitoring of production lines starting from the refining process down to packaging of final products. In inventory management, we are using the IoT. We are having plant safety and security. Combined with big data analysis, it can improve the overall workers' security and the safety in a plant. Quality control with the IoT sensors, we could collect and aggregate the product data and third-party syndicated data from various stages, and it will help for the quality control of a manufacturing plant. We could have the packaging optimization. By using IoT sensors, manufacturers can gain insights into the usage patterns and the handling of product from multiple customers. We are using the IoT in the logistics and supply chain optimization. Here, the IIoT provides the access to real-time supply chain information by tracking the materials, equipments and products as they move through the supply chain. Now, we move towards the architecture. That is how the IoT, the applications, the network, the devices, they are connected with each other. So there is no single and general agreement that is what is the standard architecture for the IoT, but still the most recommended one, they are the 3-layer architectures, 4-layer architecture, and some researchers, they have also given the 5-layer architecture. In the 5-layer architecture, what the main focus has been put? The main focus has been put on the security and the privacy. So these are the three important architectures of IoT. In the three-layer architecture, we are having the perception layer. That is all the devices, physical devices, they are sitting at this layer. The communication layer, here it is known by the name network layer, and above we are having the application layer. Now in the fourth layer, what the researchers they have done to support, they have provided an additional layer, that is a support layer, and rest of the layers they remain the same, and they put the support layer between the perception layer and the network layer. In the 5 layer, we have included the business logic. So here we are having the perception layer, then we are having the transport layer, processing layer, application layer, and above that we are having the business layer, which corresponds to a business logic. Let's start with the 3-layer architecture. And the perception layer, we are having the physical devices. Network layer, it comprises of the wireless, wired networks, protocols, topologies, and so on. At the application layer, we are having smart home or the wearable devices, we are having the hospital, that is the applications which are being deployed according to the area use case. So what is the perception layer? Here the sensors, we are having sensors which are sensing and gathering the information about the environment. In the network layer, it is basically responsible for connecting and communicating the devices. This communication or the connection may be between the devices or between the devices and the applications. And above we are having the application layer, which is responsible for delivering application specific services to the user. It defines various applications in which the IoT can be deployed, for example, smart homes, smart hospitals, smart city, etc. In the 4-layer architecture, the 3 layers, they remain the same. We are having, we have added a layer that is a support layer. So what the support layer does? Basically, it is done to include the security in the architecture. Information is sent directly to the network layer in the 3 layer, and that is why the data is being more prone to the attacks. So due to the flaws that were available in the 3 layer, a new layer is proposed. In this, information is sent to a support layer. That the support layer has 2 responsibilities. It confirms that the information is sent by the authenticated users, and it protects the information from the threats. So there are many ways to verify or authenticate the users. The most common one is the authentication. Here we could, this can be done with the help of pre-shared secrets or with the help of keys and passwords or OTPs. Now the second is sending the information to the network layer in a protected manner. So the medium is to network can be, here the support layer is sending the data after encryption or performing any other technique, sending the data to the through wireless or the wired based network to the third layer here, that is your network layer. In the 5-layer architecture, we have seen that corresponding to perception, we are having again the devices, they are the perception layer, but here we have other 4 layers above the perception layer. So the as we can see, the transport layer, it is sitting above the perception layer. So it transfers it gets the sensor data and it transfers the sensor data to the processing layer and vice versa. Here the network, it can be my wireless, 3G, LAN, Bluetooth, RFID, NFC. That is the network layer which we are having. It is basically the main concept which has been used here. It has shifted to the transport layer. The functioning is shifted to the transport layer. Processing layer, another name of the processing layer is the middleware layer. It stores, analyzes and processes huge amount of data that comes from the transport data. That is, analyzing and processing part has been capped in this layer. It can manage and provide a diverse set of services to its lower layers. It employs many technology. It does, for example, cloud computing, database, edge computing, etc., etc. Above processing layer, the business layer, which manages the whole IoT system, including applications. So application layer, the role is same. So above we are having the business layer. What's its role? It includes the application for business and profit models and users privacy. The business layer basically is being for analyzing the data for the business. IoT challenges, what are the very first challenge is the security, privacy and data sharing. Because the IoT devices, they are closely connected. So all a hacker has to do is exploit any one vulnerability on a single device, and through that, if you manipulate a single device, then it implies you can manipulate or you can hack the whole IoT network. So manufacturers, and also the manufacturers, they don't update their devices regularly, and this is the reason that we are having the vulnerable points or the soft points available with the devices, which the cyber criminals, they can exploit. However, hackers aren't only the threat to the IoT. Privacy is another important concern for the IoT users. For example, companies that make and distribute consumer IoT devices could use those devices to obtain the user's personal information. For example, your smartwatches. We are having the challenges with in the IoT concept also. Again, the same security of the data, it is the main issue. Reliability and the stability for the IIoT sensors, then the connectivity of all the systems in the IIoT setup. So no maintain, how we are going to maintain that particular IIoT network, it is a main challenge. Then blending the legacy system, since IIoT is built up over already existing manufacturing unit or your industry, then in that case, how this concept or how the IIoT application with integrate with your legacy system. These are the references which I have used while preparing the slides. So this is all about the introduction of IoT, what are the advantages, challenges, what are various IoT applications and the IoT architecture. Thank you and Jai.